Good afternoon, everyone. Good evening, everyone, and welcome to this lecture. We are dealing with the series and parallel combination of capacitors, and we will go ahead and solve more problems on this. Remember, whenever you are encountering any problem on series and parallel combination, the more the number of problems that you solve, the better you are going to become. So it's all about practice. If you do more and more practice, you shall become better in this. Having said that, let us move on to the first problem. And the first problem looks like this. This is the first problem that we are going to encounter in capacitors. We have to find the effective capacitance between point A and point B. I'll give you 2 minutes to think about this and give me the answer. Anyone has seen the question? 2 minutes you have to give me the answer. How did you get 3 as the answer? Now remember, I have to find the capacitance between this point and this point, A and B. So what do? I start from the other end, and in the other side, I see this 9, this 9, and this 9. How are these three connected? This 9 and this 9 and this 9. They are connected in series. So 9, 9, 9 in series. I can remove all these three and put a 3 microfarad in place of them. Yes or no? So 999 removed 3. Now look at this 6 and this 3. This 6 and this 3 are in parallel. 6 and 3 are in parallel. So what do I have now? I can remove this 6 and 3, and in place of everything, I can just remove everything from here. 6 and 3 are in parallel, and I can put a 9 here. So everything has gone, 9 has come here. Then again what we see is 9, 9, 9 are again in parallel. So again I will get 3. I can remove these 3 capacitors and put a capacitance of 3 microfarad. I have removed all these 3 and I have put 3. Now this 3 and 6 are in parallel. So 3 and 6 are in parallel. It will become 9. So I remove everything and I put 9. Now everything has been removed. 9, 9 and 9 are in series. So the answer becomes 3 microfarad. Do we understand how I have done this? Boys, girls, we understand this?
Yes, sir.
Okay. So this is how questions have to be done. Remember, the key for solving any question here is practice, practice, and more practice. The more the number of questions that you are going to do, the better you are going to become. I hope everyone has understood this. Can I move on to the next question? Yes? Now, moving on to the next question will require that we understand something, one more small concept, and that small concept is known as a balance Wheatstone bridge. Have we discussed this balance Wheatstone bridge before? This concept is known as the concept of balance Wheatstone bridge. Now, what is this concept of balance Wheatstone bridge? Now, if you have 5 capacitors connected like this, let me name them. Let me call this as C1. Let me call this as C2. Let me call this as C3. And let me call this as C4. And the middle one, let us call it as C5. Now, if you have 5 capacitors connected like this, This is known as a Wheatstone bridge. Now, to understand which capacitor are in series and parallel, it becomes very difficult. But if a condition is given, and you can see that condition, and what is this condition? Look at this C1 and look at this C2. And if the condition is such that C1 by C2, the ratio of C1 by C2, and look at on the other arm, we call this as the left arm and this one as the right arm, and you look at the right arm and you see C3 and C4, and you then realize that C1 by C2 is equal to C3 by C4. If you realize this, that C1 by C2 is equal to C3 by C4, then this combination becomes, then this arrangement is known as a balanced Wheatstone bridge. Now, as soon as the arrangement becomes a balanced Wheatstone bridge, then what happens, beta? Then what you can do is, if I call this point as C and if I call this point as D, this point C and D actually become same. The potential of point C and point D becomes same. Now, as soon as the potential of these points C and D becomes same, the central capacitor, the middle capacitor, the C5 capacitor actually does not get any charge. So what you can do is you can cut this capacitance out of the circuit. So this capacitance is no longer needed now. Now, as soon as the capacitor C5 is removed, now you can see that the C1 and C2 have now come in parallel. So I can write C1 is in parallel with C2, and this C3 and C4 are in series. C3 and C4 is also in parallel. C3 is in parallel with C4, and the combination of this C1 and C2 parallel and the combination of C4 and C3 in parallel, these two combinations are in series. So C1 and C2 in parallel will be series with C3 and C4, and hence you can find out the effective capacitance between A and B. This is the first way of doing it. The second way of doing it is like this. You can take C1 and C3 in series. So I can say the second way, C1 and C2 in C1 and C3 in series. Then the lower branch, C2 and C4 are in series. C2 and C4 series. And then these two branches, the upper branch and the lower branch, these two branches come in parallel. So once it becomes a balanced Wheatstone bridge, once it becomes a balanced Wheatstone bridge, once it becomes a balanced Wheatstone bridge, the question becomes very, very simple, and we can solve it in any fashion that we understand. Do we understand this? This is known as a balanced Wheatstone bridge, and most of the questions that come may be from this balanced Wheatstone bridge. Now, let me present a question to you. Anyone has noted this down?
One minute, sir.
Okay, note it down. Let me know once you are done so that I can give you the question. Here is the question, and all the capacitors are of 6 microfarad. C1 is 6, C2 is 6, C3 is 6, C4 is 6, C5 is 6. The question that has been asked is, what is the effective capacitance between A and B? And I'll give you 2 minutes to solve it. That is correct. The answer is 6. Now, how do you get the answer as 6? As soon as you see these 5 capacitors, you look at this one. This is 6. This is 6. 6, 6. And you look at this 6 and 6. So you can see the ratio of left hand side and right hand side are same. That means this becomes a balanced Wheatstone bridge. If it becomes a balanced Wheatstone bridge, then you can cut this capacitor off. Now you can solve it in 2 ways. You can take this 6 and 6 in parallel. How much is 6 and 6 in parallel? 6 and 6 in parallel. How much it will give you?
12.
12. Then you can take this 6 and this 6 in parallel. It will give you 12.
12.
Then you can take these two in series. 12 and 12 in series. The answer is 6. Do we understand this?
Yes, sir.
Or you could have done it in this way also. You could have taken the upper row in series. So 6 and 6 in series is 3. Then you could have taken the lower row in series. 6 and 6 in series is again 3. Then the upper row and the lower row is in parallel. 3 in parallel with 3. The answer is 6. So no matter how you do it, you will always end up with the same answer. Do we understand this?
Yes, sir.
Okay, can you move on to the next question?
Yes, sir.
Okay, so this is the next question. And I am going to give you. Do it aram se patiently. Don't worry. You will get the answer. So the question is like this. This capacitor is 3 microfarad. This capacitor is 3 microfarad. This is 3. This is 3. And this is 5 microfarad. Can you find out the effective capacitance between A and B? That is the question. Simple question with a simple answer. I hope you can give me the answer for this one. Very simple question has come.
Sir, 3 is the answer.
Yes, 3 is the answer. The answer is 3. How did you get it? Again, as you can see, this 3, this is 3, this is 3. 3 by 3. This is 3, this is 3. 3 by 3 is same as 3 by 3. So this becomes a balanced Wheatstone bridge. So whatever is in between, it goes away. Now there are 2 ways of doing it. You can do it anyways. I always do it this way. 3 and 3 are in parallel. So it becomes 6. 3 and 3 are in parallel. So it becomes 6. 6 and 6 are in series. So it becomes 3. Now you can understand if all the capacitors are same, the answer is always going to come as same. Do you understand this? Yes or no? No, yes.
Yes, sir.
So I can
Yes,
see
sir.
it's a simple case and I hope you are able to understand. Remember, the more the number of questions you do in this type, the better you are going to become, because this is all about your practice. The more you practice, the more circuits you do, it will be easier for you to understand which are in series and which are in parallel. Let me give you one more. Let me give you this one. And I hope you can give an answer for this one fast. So here it comes on your screens now. You have to find out the effective capacitance between A and B. I'll give you 2 minutes. to give me the answer. So, first of all, I look at this one. I see 1 microfarad. I see 2 microfarad. On the right hand side, I see 3 and 6. 1 by 2 is same as 3 by 6. So what does it become? It becomes a balanced Wheatstone bridge. We understand this, yes or no? It becomes a balanced Wheatstone bridge. That's it. Then I will solve it. 1 and 2 are in parallel. It becomes 3. 3 and 6 are in parallel. Sorry, I forgot to tell you that this goes away. 1 and 2 are in parallel. It becomes 3. 3 and 6 are in parallel. It becomes 9. 9 and 3 are in series. 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 So effective capacitance becomes 9 into 3 divided by 9 plus 3. And the answer is 27 by 12, which is 9 by 4.
Sir, the answer is 9 by 4.
Okay, so we understand how this is done.
Yes, sir.
It's a pretty simple question with a pretty straightforward answer. Let us see if you can do this one, and I will give you sufficient time to solve it. This is the next question in line, and it comes on your screen now. You have to find the effective capacitance between A and B. I'll give you 2 minutes to solve it. Yes, the answer for this one is also 9 by 4. The answer for this one is also 9 by 4. Now, how do you get the same answer? So what you can do is you can simply compare these two diagrams. Now, if I call this point as C and if I call this point as D, here it is C and here it is D. Now I connect this 5 microfarad like this, or jig 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 jig. I connect it like this, jig 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 jig, or connect it jig 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 like this. The question remains same, yes or no? No matter how I connect the capacitor between C and D, my dear friends, the question remains same. Do we understand this? Yes or no? No or yes?
Yes, sir.
No matter how I connect, between C and D, the question remains same. So this question is exactly similar to the previous question, and therefore the answer is same. We understand this? Yes or no? No or yes? We understand this? Huh?
Yes, sir.
Say na, otherwise I get confused whether you have understood or not. So the answer remains same, and the answer in this case also is 9 by 4. Everyone understand this? Please give me a raise hand that we understand this, sir. We understand this, sir, everyone? Great. Shall we move ahead in life then?
Yes, sir.
Okay. Then I will give you the next question. And what is the next question? The next question looks like this. Let me get it for you. Okay. Here comes the next question. I'm constantly looking for good and new questions. This is the next question, and I'll give you 2 minutes to tell me the answer for this one. What is the answer for this one? You have to find the effective capacitance between A and B. 2 minutes you have. Everyone got the answer for this? It is still 9 by 4. The answer still remains 9 by 4. Now, who is going to make me understand how it is 9 by 4? I don't see it. For me, it is difficult to see. How do you see it? How do you get it as 9 by 4? That is what I'm asking. Yes, can anyone make me understand how it is 9 by 4? How is the answer 9 by 4? Please make me understand. I can't understand it. Abhiram is giving me a description. Yes, Abhiram, what is your description?
Sir,
Yes?
1 microfarad and 2 microfarad are in parallel.
How we have understood? I can't see it. I can't see it. How can you see it? That is what I'm asking. How did you understand this? Yes, it is correct. Your answer is correct. And they are in parallel. Yes, they are in parallel. I just want to understand how did you get that they are in parallel? That is my entire thing that I want to understand. How do you understand this? So basically what we are going to do here, I've taken a lot of time. Basically what we are going to do here, I just want to make my point clear that I will just have a, okay, I think I can do it in this thing as well. I can just reduce the size of the diagram so that I get space to draw. So basically what I'm going to do here is redraw the circuit just to make you understand. Once you understand it, you will be able to do it. Now see, this point is definitely A, but I can't call this point as A because there is a capacitor connected here. So I call this point as C. This point is definitely B. The point on the other side cannot be B. It has to be different. So it has to be D. So basically I have 4 points here. And in between those 4 points, 5 capacitors are connected. Do we see this? 5 capacitors are connected between those 4 points. Now what do? Is I redraw the circuit. So I start from point A and I see between A and C, between point A and C, this yellow capacitor is connected between A and C. Between A and C, this yellow capacitor is connected, which is of 1 microfarad. So I write here 1 and I write, oops, wrong color. I hate wrong colors. This yellow capacitor I have connected between A and C. Now I go to D and what do I see? I see a pink capacitor between A and D. So I will just draw point D and I will draw that pink capacitor and the value of that pink capacitor is 2. Then I see a blue capacitor between C and D, that is 5 microfarad. So now I need to draw this. So I draw this 5 microfarad blue capacitor between C and D. I repeat this process. I see a green capacitor between C and B. So this is my B. I see the green capacitor. This is the, oops, wrong color again. This is the green capacitor and I see the value is 3 microfarad. What is remaining is this one. So I just color it this way. And between D and B it is connected. So I just connect it between D and B. This is this capacitor. And as soon as I write it, 6. Now, as soon as I draw this diagram, what I have drawn is I have just redrawn the circuit. In a different way. And what do you see? This is the same circuit that we were doing in the previous question, or the same circuit that we were doing in the previous question. 1 and 2 are in parallel, 3 and 6 are in parallel, and then they are in series. Do we understand this? Yes?
Yes, sir.
So the answer still remains 9 by 4. So the answer for this one is 9 by 4. Do we understand this? Or this has gone above her head saying bye bye sir, bye bye sir, bye bye sir. Please don't bother us sir, bye bye sir. We understand this?
Yes, sir.
Then a quick one for you. Look at this and tell me the answer. Answer for this one. This is 3, this is 3, this is 3, and this is 3, and this one is 5 microfarad. What is the effective capacitance between A and B? What is the effective capacitance between A and B? And I wait for your answers. Will I get an answer? I'll give you 1 minute. And how do I get the answer 3, sir? You can just imagine that this is an exact copy of the previous question. This is 3 and this is 3. This is the left arm. Do we understand this? This is the
Yes,
left
sir.
side arm. This is 3 and this is 3. This is the right side arm. So this basically this blue one, it gets cancelled. 3 and 3. And again, all of them are 3. So the answer will be 3. We have done it many times. Yes or no?
Yes, sir.
Yes, sir.
Okay, so that is the answer for this one, sir. Well done, sir. We have taken some huge steps today, and I am very happy about it. Can we do this one? When can we take one more small step? One small step for man, a giant leap for mankind. Who said this? One small step of man, a giant leap for mankind. Who said this? And when? Neil Armstrong, when he landed on the moon, sir. Yes, sir, Abhiram, sir. That is correct, sir. Neil Armstrong, when he landed on the moon, that was the statement that he made. A well rehearsed one. Small step for man, a giant leap for mankind. His friend was Buzz Aldrin. He never landed on moon. He was the second person to land on moon. The third person was in the rover doing nothing. Neil Armstrong and Buzz Elvin Aldrin. Two people to land on moon. Ah, this is the question. We have to land on this moon. And then we will repeat the same statement. Small step of man, a giant leap for mankind. What is the effective capacitance between A and B? And I shall give you 2 minutes, complete 2 minutes, 120 seconds to do this. I have the answer straight away. 4, sir. 4 is not the answer, sir. 8 is the answer, sir. Answer is 8 for this one. I'll give you 2 more minutes to think about it. Let everyone try. Let me give you
Sir, 8, sir.
time to try. Giving you time to try. How are we supposed to get this? So, as soon as you see this 2 here and this 4 here, this 4 here and this 8 here, you must say, Wallah, because now you understand that the upper thing is a V-stone bridge and this blue wala will say bye-bye. Do we understand this?
Yes, sir.
This 2 and 4 come in parallel, sir. So this becomes 6, sir. This 4 and 8 come in parallel, sir. So this becomes 12, sir. This 6 and 12, sir, come in
Answer 8, sir.
6 and 12 come in series, sir. So the effective capacitance becomes 12 into 6 divided by 12 plus 6, and I think that is equal to 4, sir. So on the top we have one capacitance which is 4, sir. In the bottom row we have one capacitance which is 4, sir. This 4, sir, and this 4, sir, are in parallel, sir. So the total capacitance becomes 8, sir. So the answer is 8. We understand this, yes or no?
Yes, sir.
Everyone, sir?
Yes, sir.
Okay, sir. Then one more question comes for us, sir. Now you can see the bridge is getting bigger and bigger. One small step of man, a giant leap for mankind. Can we take the step again? This is the next step. You have to find the effective capacitance between A and B. See, the diagram looks so difficult, but we should be able to deal with this. Yes or no, no, yes, no, yes, yes or no. You have 2 minutes to give me the answer for this one. So how do we get answer, sir, here, sir? 2 and 4. 4 and 8. This becomes a valence Wheatstone bridge. This says bye-bye. This is 4. And this is also 4. This is 8. And this is, oops, wrong color. I hate wrong colors. This is 8 and this is 8. The middle one also becomes a Wheatstone bridge. So basically this also goes away. This is 4, this is 2. This is 8, this is 4. Goes away. Everything goes away. Then you can do it in any way that you feel like. Beach wale connection goes away. You can do it in any ways. These two are in parallel. 6. These two are in parallel. 12. 6 and 12 are in series. 4. Upar wala branch 4. Niche wala branch will also come 4. Yes or no? You can do it in any 10,000 different ways. Do we understand this?
Yes, sir.
Upar wala branch 4. Niche wala branch is 4. The above branch 4. Below branch 4. The
Yes, sir.
8. And 8 is the answer that I was looking for. Everything is good? Do we understand this?
Yes, sir.
Well done, sir. Then the next one, sir.
Wait, sir.
Wait, sir.
Got it? Noted it down? Shall we move ahead?
Yes, sir.
Then this one, sir. You have to find out the effective capacitance between A and B, sir. What is the answer for this one, sir? Yes?
Sir,
Yes.
is it 3C, sir?
Yes?
Is it 3C, sir?
No, it is not 3C, sir. You can see, sir, that this capacitor will go out. Yes or no? Beach wala capacitor, this will get disappeared. This will disappear. So basically these two capacitors will disappear because of this by this is equal to this by this, and that is also equal to this by this. Do we understand this? Yes.
Yes, sir.
So beach wale capacitors go away, then you can see C in series becomes C by 3, C in series becomes C by 3, and then these two branches are in parallel. So C by 3 in parallel with C by 3, answer is 2, oops, wrong color, I hate wrong colors, 2C by 3 is the answer. Everyone got this? Yes or no? No or yes?
Yes, sir.
That is well done. One last question to wrap it up. Remember, not everything would be a V-stone bridge. Since we have done so many V-stone bridge, don't forget that without even V-stone bridge, some question can be done without the V-stone bridge. This one, to wrap up the class for today, what is the effective capacitance between A and B? So don't just get confused. What is the effective capacitance between A and B here in this case? So, any answers here? These two are in series, yes or no?
Yes, sir.
2 and 2 in series becomes 1. Then this will be in parallel with this. So 1 and 1 in parallel again becomes 2. Getting my point? 2 is the answer. No, 1 is the answer. Then this 2 and this 2 will come in series. 2 and 2 in series again becomes 1. Then this 1, sorry. Then this 1 will come in parallel with this 1. It will again become 2. Then this 2 will come in series with this one. 2 and 2 will again become 1. Then this 1 will again become 2. 1 plus 1. Then finally, this 2 and 2 will come in series, and the final answer would be 1. Do we understand this? We start from one end and we go to the next end. This brings us to an end of this class. In the next class, we'll move ahead. Remember, the series parallel will come once again in the chapter on resistance. Then also we will do it, or what I will do is we will do more series parallel with resistance also. Let's see how we go about it. So if we do resistance wala part also, then we will not do it again. Let me see how we go about it. So take care. I hope everyone understood what happened in today's class. So take care. I'll see you tomorrow. God bless all of you. Bye bye.
Bye, sir. Take care, sir.
Take care.